Is artificial intelligence for the environment still just a hypothetical, a slide in someone's pitch deck, or is it already out there, right now, keeping rivers clean and forests standing? After digging through the evidence, I can give you a straight answer. This is not speculation. Real AI systems are already helping rangers, water technicians, and emergency teams protect this planet, today, not as a pilot, not as a promise, but as working tools reaching real communities, from East Africa to the Amazon. That's what this video is about. Hello, if we have not met before, I am the digital avatar of Dr. Alan Ross. Alan researches, writes, and oversees everything in this video and our twice-monthly global webinars. I am helping to spread AI information to the developing world, while he is busy researching the next topic for our webinars and preparing the weekly summaries of important AI developments for government officials, AI entrepreneurs, and AI academies. Across every success story we found, 5 reusable technology patterns keep showing up. Earth observation and computer vision classify satellite or drone imagery, spotting floods, waste, and vanishing forest cover from above. Internet of Things and Edge AI interpret data right next to the sensor or camera, which matters when connectivity is patchy. Predictive machine learning forecasts a risk or probability, so responders can act before an event, not just report on it afterwards. Acoustic AI recognizes sound signatures, chainsaws, gunshots, even wildlife, giving continuous ears in places you can't watch around the clock. And digital public platforms share maps, alerts, and evidence, so government, communities, and civil society are working from the same picture. None of these are magic. Each is a service bundle: data access, a locally validated model, an accountable user, a response protocol, and a way of measuring whether anyone actually responded. Let's look at what this means in practice, starting with water. The best current example is WaterScope, an open-source portable testing platform that uses machine learning classification to count E. coli colonies and digitize the results. In field trials across East Africa, testing 130 environmental samples in Juba and Kawangware, the system detected bacterial contamination within 8 hours in 67% of cases. Why does that matter? In low-resource water, sanitation and hygiene settings, laboratory testing is often slow, scarce, and hard to standardize. A portable digital kit can move that testing closer to a borehole, a school, a clinic, or an emergency response, and put results on a shared dashboard. The AI here is doing something narrow and honest, classifying images of colonies, not making unsupported claims that water is safe. Rural providers and municipal health departments could start with a 3-month validation against accredited lab methods, then build a protocol for who gets alerted, who retests, and who communicates the risk. Next, waste. Conventional waste inspection is reactive. Officials can only check the places they visit. In Guatemala, UNDP, the SDG AI Lab and Politecnico di Milano combined GIS data, high-resolution aerial imagery, computer vision and machine learning to identify illegal dumping sites, including areas near Lake Atitlán. In early results, the system flagged more than 1,200 potential sites. Notice that word, potential. Human verification and municipal follow-through are still essential before enforcement or cleanup happens. But this geospatial triage approach lets limited crews focus where they're actually needed, and similar waste detection work is already running in the Philippines, Serbia, and Vietnam. Scaling this responsibly means building a local feedback loop, where inspectors mark whether each flag was real, missed, or false, and the model keeps learning from that. Now, climate. Google's Flood Hub applies machine learning to hydrological, weather, satellite, and gauge data to forecast river floods up to 7 days ahead. Its most recent technical overview reported coverage in more than 80 countries, reaching an estimated 460 million people, building on earlier work in India and Bangladesh that alone reached over 200 million people. But a forecast on its own saves nobody. In a provider survey, 65% of people who received a flood warning said they took protective action because of it. In Assam, India, The Red Cross has used flood hub forecasts to coordinate thousands of volunteers. The pattern that actually transfers is AI forecast, local operating procedure, community action, with offline SMS and radio channels kept alive for anyone without a smartphone. Turning to the ocean. Global Fishing Watch combines vessel tracking data, satellite imagery, and machine learning to map fishing activity, including vessels that go dark and stop broadcasting their location. A 2024 research release using this technology found that 75% of the world's industrial fishing vessels were absent from public monitoring systems, and that real fishing activity was 4 times larger than previously mapped. For coastal developing states with huge exclusive economic zones and tiny patrol budgets, that visibility is transformative. Though it's worth being clear, the platform doesn't prove illegality, it generates leads for authorities to investigate. Pair that ocean-scale view with something like FishFace in Indonesia, an AI system trialed by YKAN that identifies fish species from landing site images. YKAN reports 99% accuracy in initial trials, a promising provider-reported figure worth independently confirming as it scales across more ports and species. And finally, biodiversity. Rainforest Connection deploys solar-powered acoustic sensors, called Guardians, deep in forests, using AI to recognize the sound of chainsaws, vehicles, and gunshots in real time. In West Sumatra, Indonesia, 27 of these Guardian sensors are monitoring the forest soundscape and sending chainsaw alerts straight to community patrols. Deployments now span Peru, Brazil, Tanzania, Indonesia, Poland, Costa Rica, and Ecuador. In Kenya, a newer project called M-Situ combines AI, IoT, and real-time detection of deforestation and fire. In a Ngong forest pilot, the provider reported 24% fewer logging incidents and detections 85% faster than manual patrols. Encouraging numbers, and still provider reported. So what should leaders actually do with all of this? 5 things. Start with a defined operational decision. Which ranger, analyst, or community responder acts on which alert and within what time? Fund a 6 to 12-month local validation comparing AI-supported work against the current baseline, including false positives and cost per verified action. Put data rights, consent, security, and community benefit sharing into the procurement terms from day one, especially for indigenous territories and small-scale fisheries. Require interoperability and exportable data, and avoid contracts that lock public agencies into a black box. And publish outcomes, not hype. Response time, verified incidents, cost, uptime, and who actually benefits. The prize here was never a dashboard full of alerts. It's a stronger public and community capability to protect water, cut waste, get ahead of disasters, safeguard ocean livelihoods, and defend biodiversity. The most credible AI for planet investments are the ones that are modest in their claims, rigorous in their measurement, and ambitious about the human systems behind them. If this was useful, stay with me, because next we'll look at what it actually takes to bring one of these systems into your own country or organization. The newly published World Bank World Development Report, WDR, strongly supports use of AI and recommends that all developing countries should adopt AI before it is too late. Allen has circulated a concept note arguing that in order for the developing world to fully utilize the recommendations of the World Development Report, there needs to be examples that they can see which will show them how best to integrate AI into their countries to fast-track development. He has also suggested that a global AI Solutions Implementation Fund, GASIF, be established with funding from frontier model and big tech companies to finance a global program applying the 100 most successful AI solutions across the global south. Contact Allen if you want a copy of his concept note. Allen is also developing 3 not-for-profit organizations to help the developing world keep abreast of AI and technology advances that will have impacts on their lives and livelihoods. These 3 networks, the International Association of AI Agent Developers, known as IAAD, the World AI Academies Association, known as WAAA, and the Global AI Advocates Network, known as GAAN, encourage different groups to see the opportunities and to take action to avoid the potential problems. Join us. Together we can make sure no one is left behind. If you found this content of interest, please check out the free downloadable resources on our websites, including 5 introductory books on AI available in 31 languages. And join us at our twice-monthly webinars on important AI issues. And please subscribe, like and share this video so you and others are informed every time we upload something new. Thank you, and I hope to see you soon.